Okay, welcome back. This is part two. So in this video, I will be going over the rest of the equations. So let's get into this. Okay, so where we left off was I was beginning to write out the complete ionic equation of this equation here, and we did the reactants. So now we do the products. And so again, here I have an aqueous ionic substance. So the ions are going to be separated into solution because that's the way they really are. So these ions are really not together, they are separated. So that's what aqueous means, is that they are dissolved. The ions are separated, floating around separately in solution. So then the KNO3 here will be separate. So I'll have K plus aqueous. And I have 2 there, so I'm going to have a 2 coefficient in front of there. And I have 2 NO3s, so that will also be aqueous, so NO3 minus aqueous. And then I have the PbI2 solid. And so remember, solids, liquids, and gases are stay together. Only the aqueous substances are separated in the complete ionic equation. So that'll be plus PbI2, and that'll be solid. And so now what we're trying to do to figure out what our final reaction equation is going to be, we eliminate the spectator ions. And so again, the spectator ions are the ions that are that don't change. So they're the same on one side as they are on the other. So we're looking for somethings that don't change. So here we have Pb2 by itself. So we have Pb ion, the lead 2 ion, aqueous, but here we find it as part of a solid. So that's a change. So that's not going to be a spectator ion. Here we have 2 nitrates aqueous, and here we have 2 nitrates aqueous. So that stays the same. So that is not involved in any reaction. So it's going to be a spectator ion. So we can get rid of those. Here we have 2K plus aqueous, and here we have 2K plus aqueous. So those are also going to be spectator ions. There's no change there. And then here we have 2I plus, or 2I minus the iodide ion, and here we have the 2 ions in the solid. So that is a change, so that's not going to be a spectator ion. So now to write the final one, we just write it without the spectator ions. So finally, we would write Pb2 plus aqueous. These are gone, and then we have 2I minus. So plus 2I minus aqueous, and that's going to go to this product here. So that's going to be PbI2 solid. So this would be our final equation for this reaction. And so now for number 5, the last one, here we have a solution of silver nitrate mixed with a solution of potassium chloride. So we got to write out our reactants. So we have silver nitrate. So again, silver is a plus charge. Nitrate is NO3 minus. So we have a plus 1, negative 1. So 1 each will balance out. So we just write AgNO3, and that's aqueous. So whenever they say solution, that means it's an aqueous. That means it's dissolved in water. So solution of this means that we have the ions. This substance is dissolved in water, so the ions are separated. This is aqueous. And then we're going to add to that potassium chloride. So the potassium chloride is the other solution. So again, for the potassium chloride, it has potassium, which is going to be a +1 charge, and the chloride ion, which is a -1 charge. So again, +1, -1, they cancel each other out. So I only need one each of those. So it'd be KCl, and that's going to be aqueous there. And so then these are going to form our products. So once again, we have two ionic substances. So this is the hallmark of a double displacement reaction. So the inside ions are going to go together, the outside ions are going to go together. And so here, the two inside ions are the nitrate and the potassium. So those are going to go together. Potassium is a +1. Nitrate is a -1, so one each. So KNO3 goes together. So that's going to be something. We'll determine whether that's a precipitate or aqueous. And then the outside ions, so the silver and the chloride go together. So silver, chloride. And again, chloride and silver are both +1, -1, so I only need one each to balance the charge. So AgCl is the formula for this product. And so let's balance the formula, or balance the equation. So we have one silver, so that's balanced. One nitrate, that's balanced. One potassium, that's balanced. One chloride and one chloride, that's balanced. So right now we have a balanced equation. We don't need to do anything. So now we have our balanced equation. So then we use our solubility rules, look at our solubility table to see which one, if any, is a precipitate. Now, if it turns out that both of these are aqueous, then there's no reaction. If one of them is a precipitate, then we have a reaction. Okay, so we know from our solubility table that all nitrates are soluble. So since we have a nitrate here, this is going to be soluble, and so therefore it's aqueous. So it's dissolved in water. And then here we have silver chloride. According to the solubility table, chlorides are generally soluble. So if you have a chloride, it's going to be aqueous. However, there are exceptions, and silver is one of those exceptions. So although chlorides generally are soluble and therefore aqueous, this one is not soluble. So this means it's going to be a solid, a precipitate. So now that we have figured out that we have a reaction and we formed a solid, finally we need to write out our net ionic equation for this. So we have to write out the complete ionic equation where we separate the ions that are aqueous. So here we have silver nitrate, so that's going to be separated. We have silver nitrate here, so that's going to be silver plus aqueous. And then the nitrate, we have one nitrate, so that's going to be NO3 minus aqueous. And then we do the same thing for this aqueous solution here. So the potassium and chloride ions get separated. We have one each, so that's going to be K plus aqueous plus, and then the chloride ion Cl minus aqueous. And so now the two aqueous compounds have been separated into their ions, aqueous ions, and then we do the same for the product side. So the KNO3 will be separated, so that's going to be K plus aqueous plus the nitrate, NO3 minus aqueous. And then finally, we have our silver chloride. Silver chloride is a solid, so that's going to stay together. We're not going to separate those ions. So remember, solids, liquids, and gases stay together. So this is going to be AgCl solid, so that stays together. Now, what of our spectator ions? We got to eliminate the spectator ions, and the spectator ions are the ions or substances that stay the same on both sides. So we have silver plus aqueous here, but we have silver part of a solid here, so that's a change, not a spectator ion. One nitrate aqueous over here, one nitrate aqueous over here, so that's going to be a spectator because that stays the same, no change there. So nitrate gets taken out. Potassium's K plus aqueous, so the same there. We have one on each side, so we cancel out that. And here we have chloride ion aqueous, and then chloride becomes part of the solid, so that is not a spectator ion, so we'll keep those. And so finally, the final equation is going to be Ag plus aqueous plus Cl minus aqueous goes to AgCl solid. So that is the final equation for this reaction. And so this is how you predict your products and figure out what your final equation is. I hope this is helpful. If you enjoyed this video, if you learned something from this video, if this was helpful in any way, please like the video, subscribe to my channel, hit that notification bell up there so you can be notified by other videos I put out. Put a comment down in the comment section. Let me know what you think and if you have any questions. I'd love to hear from you. Thanks for joining me and have a great day.